Do you know that just 4 million years ago, our ancestors were only 3.5 feet tall? Imagine standing in a dense jungle with no weapons, no fire, no shelter. Just your hands, your mind, and survival instinct. Yet these small, seemingly helpless creatures not only survived, but thrived in one of the most dangerous periods in Earth's history. Today, we'll discover how Australopithecus afarensis, Lucy, and her companions saved an entire species against impossible odds and laid the foundation that eventually made us modern humans. Welcome back. Today, we're traveling 4 million years back in time to the savannas of East Africa, where temperatures were extreme, predators were everywhere, and resources were severely limited. This is the story of our direct ancestors, Australopithecus afarensis, probably the most critical phase in human evolution. In this video, we'll explore how these early humans survived without any modern tools or technology. What were their daily struggles? How did they find food, escape predators, and most importantly, how did this species eventually evolve into modern humans? The most interesting part is that scientists still have many unanswered questions about their survival strategies. Some theories are controversial, some evidence is conflicting. Stay until the end because we'll discuss whether we truly understand how our ancestors survived this incredible journey. First, let me give you the proper historical context. In 1974, paleoanthropologist Donald Johanson and his team made a revolutionary discovery in the Hadar region of Ethiopia. They discovered a 3.18 million-year-old skeleton, which they named Lucy, officially Australopithecus afarensis. Before Lucy's discovery, scientists had an incomplete picture of early human evolution. But Lucy proved that 4 million years ago, a species existed in East Africa that was already bipedal, meaning they walked on 2 legs, but their brain size was still similar to chimpanzees. Geological evidence suggests that during this time period, the Pliocene epoch, Africa's climate was changing drastically. Dense forests were shrinking and grasslands were expanding. Temperature fluctuations were extreme. Monsoon patterns were unpredictable. This environmental pressure was probably a major factor in early human evolution. Archaeological sites like Laetoli in Tanzania have yielded 3.6 million-year-old footprints that clearly show these creatures walked upright. Mary Leakey's team discovered these footprints in 1976, providing direct evidence that early hominins were already adapted to savanna life. Fossil evidence suggests that Australopithecus afarensis stood approximately 3 to 4 feet tall, weighed around 30 to 45 kilograms, and had disproportionately long arms compared to modern humans. These physical characteristics gave them advantages in both ground living and tree climbing. Carbon dating and geological surveys show that this species emerged approximately 3.9 million years ago and became extinct around 2.9 million years ago, meaning their survival period was approximately 1 million years. During this time frame, Africa's climate records show multiple ice ages and warming periods. This time period was particularly challenging because megafauna like saber-toothed cats, giant hyenas, and crocodiles were dominant predators. Competition for resources was intense, and survival required incredible adaptation strategies. Here's where the story gets really interesting. Despite extensive research and thousands of fossils, scientists are still puzzled about several critical aspects of early human survival. The first major mystery is diet and food procurement. Lucy and her contemporaries' teeth suggest a mixed diet of both plant and meat consumption. But the question is, without sophisticated tools, how did these creatures obtain meat? Evidence of stone tools from their hands is minimal. Some experts argue they were scavenging, consuming meat from already dead animals, but other scientists claim early evidence of organized hunting has been found. Dr. Richard Wrangham has a controversial theory that early fire use occurred for cooking, which helped then extract nutrition. But archaeological evidence of controlled fire during this period is extremely limited. This creates a major gap in understanding. Another puzzling aspect is social organization. Fossil evidence suggests these creatures lived in groups, but exactly how their social structure worked remains unclear. Footprints at Laetoli suggest family groups, but the level of cooperation is disputed among experts. Predator avoidance was probably the biggest challenge. East Africa, 4 million years ago, was literally a death trap. Saber-toothed cats, leopards, hyenas, crocodiles, all made this same area their hunting ground. Modern primates like chimpanzees have sophisticated alarm systems and group defense strategies. But early hominins' brain size suggests limited cognitive abilities compared to modern humans. Some researchers argue that bipedalism itself was primarily an anti-predator adaptation. Standing upright gave better visibility over grasslands. But critics point out that bipedalism also made them slower runners compared to quadrupedal ancestors. Climate adaptation is also a controversial topic. Ice core data shows extreme temperature variations during this period. How did these creatures, with limited body fat and no clothing technology, survive harsh winters and extreme summers? Some theories suggest behavioral thermoregulation using caves, water bodies, and group huddling. But evidence remains circumstantial. The most intriguing mystery is cognitive evolution. The archaeological record shows gradual increase in brain size over this million-year period. But exactly what environmental pressures drove this expansion? Food processing, social cooperation, tool use, language development? The timeline for all of these remains unclear. Recent DNA analysis of ancient remains has also raised questions about interbreeding with other hominin species that existed simultaneously. Now, let me present the different theories and evidence that scientists have gathered over decades of research. Tool use theory. While sophisticated stone tools appear much later in the archaeological record, some researchers have found evidence of modified bones and sticks from this period. Dr. Raymond Dort's osteodontoceretic culture theory suggests that early hominins used animal bones, teeth, and horns as tools. Recent microscopic analysis of fossils shows wear patterns consistent with tool use, but mainstream archaeology still debates this evidence. Aquatic ape hypothesis. This controversial theory, proposed by Alistair Hardy, suggests that early humans spent significant time in water environments. Evidence includes bipedalism, which is efficient for wading, loss of body hair, subcutaneous fat distribution, and excellent swimming capabilities compared to other primates. Critics argue insufficient fossil evidence exists for aquatic lifestyle, but some coastal archaeological sites show promising data. Cooperative hunting theory. Recent studies of the Hadza people in Tanzania, one of the last hunter-gatherer societies, provide insights into possible early human strategies. Persistence hunting, where humans use endurance running to exhaust prey, could explain how early hominins obtained meat without sophisticated weapons. Fossil evidence shows leg bone adaptations consistent with long-distance running. Grandmother hypothesis. Anthropologist Kristen Hawkes proposes that post-reproductive females, grandmothers, played a crucial role in species survival by helping with childcare and food gathering. This extended childhood dependency theory explains brain growth and social cooperation development. Fire mastery theory. While controlled fire evidence is limited, some researchers point to burned bones and soil modifications at early sites. Richard Wrongham argues that cooking enabled better nutrition extraction, supporting brain development. Recent chemical analysis of ancient hearths in South Africa shows possible early fire use, but dating remains disputed. Scavenging versus hunting debate. Cut marks on animal bones found at archaeological sites show tool use, but were early hominins active hunters or passive scavengers? Bone marrow extraction evidence suggests sophisticated food processing, but debate continues about hunting capabilities. Climate refugia theory. During extreme climate fluctuations, early humans possibly survived in specific geographical refugia, areas with stable microclimates near water sources. Geological surveys identify possible refuge areas in the East African Rift Valley, but population density estimates remain speculative. Social brain hypothesis. Robin Dunbar suggests that increasing group sizes required cognitive development for social coordination. Archaeological evidence of communal living sites supports group cooperation, but exact social structures remain unknown. Modern genetic analysis provides additional clues about population bottlenecks and migration patterns, but interpreting ancient DNA remains challenging due to preservation issues. To summarize, 4 million years ago, our ancestors faced seemingly impossible survival challenges. Without modern technology, sophisticated tools, or advanced communication, Australopithecus afarensis not only survived, but laid the foundation for human civilization. Their survival strategies, whether scavenging, cooperative hunting, tool use, or social organization, directly influenced every aspect of modern human behavior. These remarkable creatures proved that intelligence, adaptation, and cooperation combined can overcome any environmental challenge. But countless mysteries still remain unsolved. Exactly how did they master fire? How did their language development occur? How were social hierarchies established? What were their specific adaptations against climate change? In the comments, tell me what you think was the most critical survival strategy in early human evolution: cooperation, tool use, or intelligence development? In the next episode, we'll explore the story of Neanderthals, our closest evolutionary cousins who mysteriously disappeared. Subscribe for notifications and continue this fascinating journey of human evolution. Until next time, keep questioning, keep exploring. This incredible story of evolution has just begun.